Here we go. So the graph that we've been working on, and I will point out on here, is up in the upper corner here, so that should look pretty familiar. And so the blue line shows the angle of inclination of the sun in Dublin over the year, and the red line shows angle of inclination for North Island. And just to clarify what angle of inclination means, I have this graphic here. To basically show you, it means that it's just the angle from the ground or the horizon to the sun. So you would do like a math, segment. How you guys do angles in math class, you draw a segment up into the sky at that particular angle, and that's where the sun would be at that time. That's what angle of inclination means. It's not temperature, it's the actual angle if you were to use a protractor. And so I want to talk about that and how that affects things on the planet in terms of temperature as well. So for example, if we're looking at the graph here, okay, what is that telling us about the angle of the sun in terms of how it's striking the surface or you? So it's about what, maybe 30 degrees, somewhere in that ballpark? Okay, what does that mean? If I say 30 degrees angle of inclination, this is January 1st in Dublin. What is that telling us about the angle of the sun in the sky? Yes?
It's telling us like where the sun is, like from the ground.
Okay, so 30 degrees is about what, if you just had to guess? Is it really high up, or is it going to be shallow, more shallow? Yeah, more shallow. Okay, 30 degrees isn't very much. Let me turn the lights off so you guys can see. So if I were to kind of simulate that with a flashlight, okay, and I want, so like if I started from 0 and then I start going up to about 30 degrees, I'm going to ballpark it about there, okay? Do you guys see that?
Yeah.
Okay, so what I'm going to do, I want to mark on the paper where all that light is hitting the paper, okay? So we'll say that this here, excuse my shaky circle, and we'll say that's about 30 degrees. Okay, does that work for you guys?
Yeah.
Okay. Now, if I go to, say, mid-year in Dublin, where is that about on the graph? What angle of inclination would that be about?
Like 75 maybe.
75, somewhere around there? Okay, we'll say 75. And 75, is that going to be more shallow or more steep than what we saw originally with 30?
Steep.
Steep, yeah. So it's going to be higher up in the sky, right? So if I did that, okay, this would be like 9. Oh man, my flashlight's not working very well. There we go. That's going to be 90. So if I go off a little bit, great. Hey, that worked. All right, so let's say that's, would you guys say that's about 75? Those of you who can see the flashlight up here that I'm holding?
Yeah.
I mean,
I thought it would be farther, like
Farther,
up the paper.
like this?
No, like a little higher.
Like this is 90 right here.
Oh.
So if I go,
yeah.
because 45 would be here, this would be 90.
Yeah.
I'll say someone between the two.
So somewhere like about there?
Yeah.
All right. So if I mark that in terms of where it falls on the paper, it's going to be about there. Would you agree?
Yeah.
Sure.
Okay, so we'll say that's approximately 75 degrees of inclination. Okay? That is a horrible looking 5. Whee! There we go. Okay, so what is different there between the two levels of inclination? Now, let me start by saying this flashlight did not change the amount of light that it was giving off. Would you agree with that?
Yes.
Okay, so same amount of light no matter what. But what changed here? All I did was tilt it. Yeah.
Like when it was 30 degrees, the light seemed to be more spread out, kind of,
Okay.
compared to when it was 75 degrees.
75 degrees was like at one area.
Yeah.
Okay, so 75 degrees was in more of like one area versus 30 degrees was more spread out. Okay. What about how it looked? And not just the size, but what about how it looked? Here, let me do it again. So here's our 75, and here's our 30. Does it look any different to you guys? I mean, minus the hole in the middle, but
It's
it's,
bright.
it's brighter like this?
Yeah,
Yeah.
brighter like.
Okay. So same amount of light both times, right? Because the flashlight's not changing. But it's brighter when it's higher, right?
Yeah.
So what might that tell us about when it's actually happening with the sun and not just a flashlight? Somebody on this side of the room. Yeah. So at a steeper inclination, it would be hotter, and what makes you say that?
Because the sunlight's more directed in one spot rather than being spread around.
All right, so the sunlight is more directed in one spot rather than being spread around. So he's saying that more direct, or it's when it's higher, it's going to be hotter. Is that the case on our graph?
Yes.
Yeah.
So if it's higher, it's here, and is it hot around July?
Yeah.
Oh yeah, right? It definitely was a hot summer.
Steam.
Okay? So more direct, meaning more intense, you're going to get hotter temperatures, right? Versus more shallow, you're spreading the same amount of light or the same amount of energy over a greater distance, right? So you're not changing the amount of energy, you're just spreading it out. Okay? It's like, I guess, you know, even though it's energy, it's still a fixed number, okay? A certain amount of energy, but when you spread it over a greater area, it's like, say, if I gave you a glass of water, okay? And you drink the whole glass. You just got all that water, right? Now, what if I take the same amount of water and I give it to the entire class? Everybody still gets water, right? But does everybody get as much as you did?
No.
Right, because it's spread out over more people. It's the same idea. Make sense?